Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I do data science and machine learning at Databricks. I'm joined by my co-host,
Ben Wilson. I build back-end stuff at Databricks.
And today we have a sort of unique episode. Our guest is Charles Max Wood, and he's actually the owner of the podcast. And it's just a little bit of a window into the man behind the curtain. Both Ben and I were guests on the podcast a while back, and we got invited back as hosts. And both of us figured, why not? Should be fun. Talk about nerdy stuff once a week. And we've been doing it, I think, Ben and I for about a year now. And then Ben was actually a guest about a year before, and he's been doing it much longer than I have. So that's the origin story. And today our guest is Chuck, Charles Max Wood. Great guy. Do you mind telling us a little bit about your background?
So where do I start? I got into Ruby on Rails back in 2005, 2006. I've pretty much been working in that area professionally for the last, how long has it been now? 16, 17 years. There was a while there where most of my focus, income, etc., was running the podcast network, right? So I was still writing software, but I was writing it for myself to help me manage the podcasts. And then lately, I had kind of a rocky period, 2019, 2020, right before COVID and then during COVID. And so I wound up working for Morgan Stanley for about a year and a half, and that was about the longest year and a half of my life. And then I picked up a contract and I was working logistics. It was a logistics company, so it was shipping and e-commerce and stuff like that. Worked for them for about a year and 3 months, and that contract ended last week. So I'm kind of focusing all of my attention on Top End Devs, which is the podcast network this show runs on. And one of the things that people keep asking me for is just more content on a couple of different topics. And I also feel like this is one area that is going to continue to grow. I think over the last year, with kind of people figuring out ChatGPT and some of the other systems out there, that people are starting to have more of an interest in machine learning. I also find that a lot of the lay people really don't understand what's going on with ChatGPT. And so, or whatever else they're using, right? Midjourney or some of the other systems that, have an engine behind them. So, anyway, what I'm looking to do, and just to give some context as we kind of get into this, is we've had a lot of conversations about how machine learning works. I kind of have a vague idea of how it goes, but I want to start actually building some machine learning systems, right? Some ways of, making decisions or pulling information out of data sets. And so, and I want to start putting out videos and just start showing people, hey, here's how you get into machine learning. Here's how you start building the engines and stuff like that. And I've looked at some books and some courses, and I'm sure they can get me started, but I thought, hey, I know some guys. And so I thought I'd just come on here and say, okay, so, how do I get started, right? How do I get rolling? Given my background is mostly in building web backends, some web front end stuff, how do I make that transition from here?
Right. So we'll use this as a case study, and potentially other software engineers looking to make a similar transition can leverage the information here to do something similar. So Chuck is going to be this theoretical full stack engineer with an emphasis on backend. And then we'll talk about the different paths that you can take to go from the software engineering skill set into data science or even machine learning engineering.
Right.
So that's where we're starting from. But Chuck, can you elaborate a bit on what the destination looks like for you?
Well, I think a lot of people, when they start looking at machine learning, they just see basically a decision machine, right? It's something that, or sometimes it's, like a recommendation engine or something like that, right? Where there's more to it than just a full text search. And so, I guess the destination would be, how do I give intelligent feedback to people, based on data that I have or data that I can find?
Yeah. So from the background that you have and people that have been doing the things that you've done for so long, you're very aligned to product, and you're very aligned to, you're going to be building something that people are going to be using, which is not the same way that, definitely not all software engineers think that way or work in that way every day. Sometimes you're creating something that it might work, or you're going to test it out and then adapt to it and change it. You still do that in the front end and with products, but you're more finely focused on, I have a problem, I need to find tools that can solve it, or build the tools, but I'm going to always find the tools before building them, because it's faster and more reliable generally.
Right.
The people that are building the models that you might use for AI, machine learning, they're not trained or programmed generally to think that way. Usually it's an abstract problem that is handed to a data scientist or a team of data scientists. The business says, I want us to do this thing. And it might be something that a human's doing right now, or a whole team is doing, or it's a functionality that just doesn't exist. If we go off of the most recent hype train, and everybody's talking about, these big LLMs, and they are super cool and super useful. But let's say that we wanted to have the ability to have a front end web app or mobile app that we can do on the fly dynamic translation, so that people can chat with one another in their native language without needing to translate it themselves. So I can write in English.
Oh, that'd be cool. Yeah.
You can write in Italian, and Michael can write in German. And to each of us, we're only seeing our native language. And an LLM can do that. And they can, there's language models that are built specifically for that translation service. And they're very sophisticated. The data scientists, when hearing about that problem, they're deconstructing that to say, well, I need to train a model, a deep learning model, a very big and complex one, with potentially tens of millions, hundreds of millions, or billions of parameters.
Right.
If they have, Scrooge McDuck money, they might build that architecture themselves, curate a data set or thousands of data sets, and train from scratch on a new architecture. It'll take them a year, maybe 2 years to build all that and train it and vet it. Or they're going to go and pull a pre-trained model from somewhere, take their own training data and augment that and run that training. But they're not thinking about the product. They're not thinking, how does this integrate with chat? Do I need to filter any words here? How do I format stuff if the translation is off? Or provide an uncertainty indicator to say, like, the sentence you typed, I tried to translate it, I wasn't really sure if this is the correct one. So that's more like the product focused stuff. And when we're talking about the difference between data science and machine learning engineering, data science is all about that model and the training data. And it's a lot of failed experiments, a lot of time, a lot of chaos, and just a lot of statistics of evaluating results and measuring them. But then the product side of that is a whole different discipline, is that machine learning engineering component, which is, how do I serve this? Where do I serve this? Where does this model live in the cloud? How many times do I have to replicate this model on how many different VMs? What infrastructure do I need to build around a REST API? How do I handle fallback? How do I handle errors and retries? All of that stuff is something that data scientists would never do. They just don't know how to do that generally, unless they're a unicorn, which is rare.
Right. So I guess my question is how do I approach this, right? Because, you're talking about how the data scientist will, pull in a lot of this data and things like that. And, honestly, it's a little overwhelming to really think about, because I don't even know what kind of data you would put in for a natural language model like this. But
and that's the trick, where a lot of companies who are thinking about applying these big models, these deep learning models, like, well, we're going to retrain it. Like, retrain it on what?
Right.
Like, oh, there's open source data sets that we can use. Like, what do you think the original model that you're using trained on?
Right.
So it's stuff like ChatGPT, OpenAI, they have a repository of all the free, clean text data sets that are out there. They use those for training. They scraped all of GitHub in public repos for training data for the code part of 3.5 and GPT-4 and GitHub Copilot. But if you're trying to do what we're talking about, that language to language translation, that's not one model. It's one model that has it'll have different instances of that model with different configurations. So we would, in our training set, we would have a sentence in English or an entire paragraph in English. That exact paragraph translated to French. That exact paragraph translated it in Italian, in German, in whatever language you choose. That's your training set. But you need millions of those. And I'm talking, even this, if you were to take all of the text in Wikipedia, I don't know if you ever tried to crawl the entire site, it's a lot of text.
I'll bet.
If you were to take that, that's not even 1/100th of the volume of text required to do the iteration of training for GPT-3.
Right.
So the volume that we're talking is insurmountable. But then where do you get that data from? These models, garbage in, garbage out, is a very true
it is.
saying
I'm sure
that people say. So if you have a messed up translation in there, the model's gonna learn that association. And every time you do a prediction, it's going to get that wrong because these models are just pattern matching machines. So if you give it the wrong pattern, it generates the wrong answer. So the key is, how do you leverage front-end skills to work in the space of data science or machine learning? One of the ways you can do that is, if you were to ask the data science team, like, hey, we need the ability for everybody at the company to generate training data. Everybody who speaks French natively, we're going to have them do English to French translations or German to French translations if they know German as well. But if the data science team is left to their own devices to create the system for generating that training data, what's it going to be in? Excel? Google Sheets? That sucks. Like, who wants to open up a shared Google Sheet and, what row was I leaving off on? 80,362. Let me scroll down there. It sucks, right?
Yeah.
And in the Excel sheet, when they get to a certain size, they're just going to bomb out the heap on your machine. And you'll be like, all right, my computer crashed, or I can't save this file anymore. So the best place to get involved in that, in my opinion, is use what you know. And your solution to something like that would be, I'm going to take a full stack for a web app. I'm going to whip together a website in an afternoon. And all it's going to do is display, the thing that I need to do the translation for, and then a text box to the right of it, and some buttons that allow me to move to the next one to save my translation. So you could save a team weeks, if not months, of effort and work by just building something like that. That's trivial for you to do, but for them, they wouldn't even know where to get started.
So I guess, you said, I could just throw up some website that, pulls together some of this stuff. And I could stick it in a database because that's what I do all day long, every day. Right. But so let's say that I have my own data set, because it seems like the data set's part of what's kind of crazy overwhelming, and I don't know if it's a large enough data set or whatever. Right. But let's say that I have, a data set of like all of the NPM packages out there or something like that. Right. And, and so I've pulled all that in, and I want to recommend to people, hey, if you're using these three, maybe you want to look at this fourth one. Right. Or things like that. Right. So, my question is, let's say that I can find a data set that I want to use. Like, how do I begin to build the model? Right. And I know that there are systems out there where I can effectively take their model, feed it my data, and it'll kind of build itself.
So I guess where I was going with my previous answer was the best way to learn how to fit into that new profession or work with those
Uh-huh.
teams is to work at a company where you're embedded with them.
Right.
So the most high functioning data science or ML, you know, departments at companies are the ones that, yeah, they have some data scientists, usually a lot of them. They'll have a bunch of ML engineers who are, data scientists who learn how to code really well and learn architecture. But then the big successful ones, they'll have 6 or 7 front engineers or full stack
Right.
developers who are embedded to build tooling to assist.
Uh-huh. Yeah.
But when you're in there, you're going to get exposed to all the things. And at
Yeah.
first, it'll be so overwhelming. But it's the same as if you take one of those data scientists, just one of them, and say, "Hey, you're gonna attend our front end stand up." They're
Right.
gonna be like, "What is going on? What are you talking about? I don't understand." So
Yeah.
it'll seem like that, but you'll be working so closely with the ML engineers more than the data scientists, building tooling to assist them, or building the actual, like, they have a model, they build
Uh-huh.
the infrastructure for serving it, and you're
Right.
building the interface to be like,
Right.
"Hey, I'm in JSON land. I'm going to pass you JSON. You're going to give me back some JSON. I'm going to
Right.
display it, and then I'm going to take that, like both parts of that, and I'm going to write it to a database because that's our training data for the
Mm-hmm.
future, for like the next iteration or the retraining." But
Right.
in that collaborative environment, within 6 months, you'll know the tooling of how to build that model, and you'll
Right.
probably have access to the raw source code of how they did it, and you can
Mm-hmm.
just start poking around and running stuff and being like,
Right.
"Oh, that's how that works."
So I like that, and I like the approach just because, I mean, that's how I've learned everything else pretty much my career, right? Because I've
Mm-hmm.
worked with either worked on a team where we were doing it, and so I had to pick it up, or worked on a team where somebody was doing it, and I could go and I could kind of pick their brain, because usually people are pretty good about, hey, you're on the team. Oh, you want to more deeply understand what we're doing here? Okay, here are the things that you need to know. Well, this is why we do it this way. This is why we think about it this way, and I really really like that. Um, so I guess the question that follows to that is, how do you find those jobs, right? Because, if I go out and look at jobs now, it's real easy for me to find a job saying, hey, we want another Rails engineer to come in and work on our back end, right? Or if I wanted to transition to front end and do something like React, same deal. I can find those jobs pretty easy. What I'm not seeing a lot of is, hey, we want you to come in and interface with our ML team, or be part of the ML team as an interface engineer. So how do you find those?
So one of the things you can do that qualifies you for, not for data science work,
Right.
nobody, I'll tell you right now, nobody's going to hire you as a data scientist, and you wouldn't want to do that anyway, because it would be so frustrating. Of like, yeah, I know how to query data, I know how to manipulate data, I can do aggregations, I can do rollups, I can parse it,
Mm-hmm.
but if somebody's like, hey, I need you to create that website that recommends NPM models, of like, hey, you're using these 5 packages,
Mm-hmm.
what are the 4 most complementary ones, and then rank them by the one thing that JavaScript developers seem to care about most of all, which is, what is the total package size for deployed, artifact. And if you were given that task without any context and background, it'd be pretty overwhelming. It's like, well, where do
Right.
I go? What do I even attempt to do? There's no documentation out there on, like, here's how you solve this exact problem. So I wouldn't try to apply for that. What I would try to do is look for those ML engineer positions, because the job requirements are mostly what software engineers need, particularly full stack people that have done back end
Uh-huh.
work. It's like, well, how do you set up stuff like, EC2 instances?
Right.
How do you set up load balancers? How do you, set up a REST API endpoint? And how do you, put, you know, traffic protection modules in front of that? So setting up that infra, that's the way to get into those teams, because the data scientists, they don't know how to do that most of the time.
Right. So it's sort of a slow transition from doing software for whatever you're doing it now versus doing software for ML specific applications. Once you start picking up ML skill sets and ML knowledge, then maybe you could continue the transition to a full data scientist if you want. But I know Ben has thoughts on that.
So
yeah, he pretty much said don't do it. But yeah, I mean, that's one thing though that I found in my career is that because I mean, even if you're just doing one technology like Ruby on Rails, right? I mean, you can do that for your career forever. At least you could so far. But you work on so many different apps that have so many different requirements and concerns and things like that. That yeah, like the core pieces of your job may remain the same, but you may be picking up other stuff anyway. And so I could see this as, yeah, I get in, I start building, support. I'm basically a support person for the ML engineers as far as like getting their models and software out there where it can be used. And then as I get deeper and deeper and deeper, I may find my sweet spot. Oh, I went way deep into the point where I, was flirting with data scientist and I got bored. Or maybe it was, hey, I never knew that things could be ever so cool, right? And so you keep going, or you stop and you pull back and you say, hey, wait a minute, I don't really enjoy this part. I really just want to be the engineer in charge of these kinds of things.
Yeah, and I haven't met anybody I've known a bunch of people who have tried to do that, who have gone from software engineering and they're like, before people were using the term machine learning engineer, and they get hired at a company as a data scientist because they're like, hey, you know how to code? This is all code, so yeah, come build stuff with us. I've never known anybody who's stayed more than 2 years in that discipline, just because it's the process of development with that is not, it's such a departure from software engineering, like traditional. Like, hey, I write this code, I write my tests, I check my code in, I go through peer review, we get this merged into a main branch. That's not how it is with data science. It's, hey, I'm going to try these 8 different things. It's going to take me 3 months of experimentation to figure out which one's most promising. And I'm going to retrain it on data 500 times before I'm even ready to say, hey, I need some help deploying this. So everybody that I've known that has done that from software engineering has transitioned naturally to this pseudo, like these terms that people keep on throwing out that kind of annoy me, but the ML ops, ML engineer, even though my freaking book is named Machine Learning Engineering in Action, but that sort of role of, it's either a software engineer who's come into supporting ML, or it's a data scientist who's worked with software engineers to get good at writing code. So that department or that team of those people come from either side of that. And they each bring something very valuable to that team, because deploying these things is so much more complex than any other software deployment that you can think of.
Right.
They're insanely complicated just because there's no pattern to it. It's not like, oh, this is how we do a recommender engine. This is like the standard way that you deploy one of these. Like, no, I guarantee every company that has one in production right now does it differently. Well, there's different stacks. There's different. It's really crazy.
Well, that's the other thing is that, I mean, again, just going back to my web development experience, everybody has a slightly different stack. And even if you're using the same tools to deploy, a lot of times you're deploying with different dependencies. You're dealing with different, database setups. You're using different libraries to give you different sets of functionality. And so what you're telling me doesn't surprise me at all, right? Even if you're doing a standard sort of setup. I think as I've talked to some people in the machine learning space, I think the most close to standardized anything that I run into is that some of them are using some of the cloud providers' machine learning engines. And so the way that they interface with that stuff looks more or less the same. And then, as far as like, hey, we're going to point at that, we're going to use their APIs, we're using their libraries to put data in and take data out. And then everything around it just, is different. And the way that they structure their data within it may actually be different too. But just, that kind of interface might be the thing that, everybody has in common that's using it.
And that stuff works fairly well for a mid-sized company.
Right.
Like you use an AWS, you're like, oh, we're just going to deploy our model artifact to SageMaker, and we'll build a container around it, and we'll deploy it. No big deal. No company that has 1 million customers uses that.
Right.
And the reason is, it's not because it doesn't scale. It scales really well. The reason that people don't use it is because you pay for that scaling. And if you start doing just basic budgetary math, you're like, hang on a second. The lift we got off this model is, $500,000 a month in extra revenue. And our AWS bill went up $2.5 million last month. Shut it off now.
Yep.
So the only way that you can build that infrastructure that scales for ML is rolling your own. You're using open source tooling. You're using the clouds, of course, but they need people that have done that before, which is you, to come in and help these teams build that out properly.
Right.
And you get exposed to all that cool data science stuff. You're like, oh, we're doing a language model, and I created a chat bot that's advanced, and I'm hitting this API. You can build some really cool stuff and learn at the same time.
Right. So yeah, and like you said before, right, I could just go look for machine learning engineer jobs and see.
Or MLOps engineer.
MLOps, yeah.
Yeah, let me take a stab at this, and I might add a little bit of flavor, but just sort of to add structure. So in my experience, there are like a variety of ML roles and a variety of data science roles. There's also data analyst, data engineer, and all of them require different skill sets.
Right.
And one of the reasons that ML and quote unquote data science is so in demand is the skill sets are giant. So theoretically, the holy grail ML engineer or data scientist would have strong software engineering background, extremely strong data engineering background, pretty strong stats or pretty strong modeling or specialize in one or the other. And then also something that's often discounted is they need to be subject matter experts at whatever they're doing sometimes. So I've seen lots of very non-technical folks who build great models because they know the deterministic system structure that they're predicting against. And so there's a bunch of different ways to be quote unquote good in this space. If you're coming into this world from a software engineering perspective, you probably have strong software engineering, reasonably strong data engineering, and then probably are lower on the stats, predictive modeling, and then subject matter expertise.
Right.
So you should look for roles that cater to that, but give you an introduction to the other areas. So we were talking about product implementation at the beginning. That would be a very logical step. You basically put your API token for ChatGPT in, and then there's your translation model. But there's a lot of other things when serving that model that you have to think about. So maybe you need to track accuracy. Maybe you need to track how it impacts user behavior. Now you're starting to get into the causal world. And then if you want to go super technical, you can go into the ML infrastructure side, which is what Ben does, ML ops, ML infrastructure. And that stuff is really, really complex. And it's a lot more software engineering based, but you have to sort of know the context of ML.
Right.
The other jobs, which are like the prototypical data scientists, people often think of those as modeling specialists. And frankly, going to that from software engineering is a bunch of steps because they're just completely different skill sets and different processes, as we've been talking about before. So Ben mentioned that like taking incremental steps into this world is a really good strategy. And I frankly agree. If you leverage the information and the skill set that you have to pick up other stuff, that's a really good method, because getting a data science job with a software engineering skill set, it's hard.
I think there's one other component that is a specialized flavor of data scientists that I've talked to people who think that it's usually not people that have worked in industry in these groups, but it's like somebody who's still in school, who's like in a post-grad position or something, or they're in an undergrad. And they're like, well, when I get to industry, am I going to be like building my own models? I'm like, well, you're going to be applying architectures of libraries to build an implementation. So it's applied machine learning. Like, oh, I thought I was going to be building like bespoke algorithms. Like, yeah, and like nobody does that. And people do it, but you're going to have to
Yeah.
go back to school for another 8 to 12 years to get the
Right.
foundations of how you do like understand the structure of how these things work. And you're going to be taking some very advanced math classes and some computer science classes that are very challenging in order to get that PhD. And then you might get hired at a company like OpenAI or Google or Meta or LinkedIn, where they have
Mhm.
research scientist groups that they're the ones that are building that stuff that ChatGPT is out of OpenAI and their research
Right.
division. Microsoft has a wonderful, amazing research division as well. But these are separate organizations within these larger organizations that they're tasked with sort of moving the line in technology, saying what's the next best thing. And they're expected to write white papers constantly and get things published and talk at symposiums. So if you want to be a scientist, like a DSS, like a true scientist, those are the people that are working on that stuff. And no, like with the exception of huge tech, and getting hired within one of those teams at one of those companies is much harder than just getting hired at that company. So it's some of the highest bars of the highest bar in order to get in there. And not a lot of people are involved in that. But I just want to add that as well. Like that's another side of this industry that is extremely rare. And there's not a lot of humans doing that right now.
Right.
So Chuck, we outlined a few sort of areas that typically a software engineer might go into.
Right.
When we're looking at your destination, what does it look like? Do you want to be writing code for ML? Do you want to be a full-on data scientist that doesn't use the software engineering skill set, but instead uses subject matter expertise and statistical modeling, let's say, to build models? What are you interested in?
Yeah, so I'm not so interested in necessarily the data scientist angle. I mean, I feel like to be competent in the machine learning, like whether it's building, using, and implementing the models, I have to have some data science skills, right? I have to be somewhat competent that way. But yeah, I mean, I'm more interested in building the system that my back end system can talk to and use, or building a system that other people, other systems can also use. That being said, it seemed like kind of the obvious way to learn these skills was to go and pick up a job, right, doing machine learning engineering. I have to say that the last two long-term positions that I've had, I mean, the one was at Morgan Stanley, and I loved the people I worked with, but I just didn't really enjoy working in a large organization like that. And some of the issues that were there really didn't appeal to me. And then I also, the last job I had, they actually got acquired by another large company, and like the last year basically of me working there, my stress levels were just off the chart because of the way that they operated. And so I'm not certain that I really want to go find a job, right, where I'm going to pick this up. I think I'm a little more interested in picking some of this up myself, or I know some people like dabble in some of these models before they go whole hog into moving to an ML team. And so yeah, I guess that's my next question is can I do this without going and getting that big corporate job or that job at some company that thinks they need machine learning?
So my Socratic question to you is, how did you learn how to look at a Grails implementation of an entire full stack deployment of an app and know how to convert that to Rails in a couple of months?
Trial and error. I mean, we had a guy on the team for a long time that, he'd kind of walk us through the Groovy on Grails code. But for the most part, even then, I don't know. It was it was still tricky to figure out, right? Because I just did not have the depth of knowledge in how Grails worked. And this is from my experience at Morgan Stanley. But sometimes we just had to dive in and look at the code, right? And kind of puzzle it out.
And that's how software engineers figure out how to implement something. If you're implementing something that's never been done before, it's lucky if they're like, hey, we want to do this thing that exists on this other website, or this other company does this thing. Can you figure out a way to do that?
Right.
We really like that. Sometimes it's so popular and so common that you're like, there's an actual module for this that does pretty much most of this work. Awesome. I'll just use that.
Mm-hmm.
But the other 80% of your work as a software engineer is, okay, there's no solution for this that I can just get like for free. I got to build this and I got to figure out how to do it. And there's this new library or this new language, this new stack for, JavaScript or something that has this functionality. A professional software engineer is going to learn that in 2 weeks. You're going to go through, read the docs, play around with stuff, and you're going to understand, because that foundation's there. Design principles, structures of code, how, it doesn't matter what language you're looking at. You're like, I know how to iterate through a list or an array.
Right.
I know how to sort things. But those fundamentals that you learn as a software engineer, data scientists don't learn that. They'd never need to know how to do that. So that skill set that you bring to that, not that team, that theoretical team, but this profession. So if you start digging into, hey, I want to do that NPM package recommender, you start looking for, type that question into Google and say, machine learning, recommend items similar to other items. Right. And then start going down that rabbit hole of, instead of looking at blog posts, because newsflash, 60-70% of the ones about ML are garbage. And they're either copying other people's stuff or they're just flat out wrong.
That's true about a lot of the content out there in tech. Is it's like, okay, I get that you had something that eventually worked, but nobody would build it that way if they had any clue how things go together.
Right. But you know how to look through those results, and all software engineers do. Like, I just want to know what packages offer this.
Right.
And you'd be like, oh, sklearn. Huh. Well, let me look at the Hello World for that. Let me check it out. Okay, now, they have an API for recommendations.
Right.
I'm going to do take the example, run it locally on my machine, see what the results are. And now I'm going to start reading the API docs. Right. And then each term that you hit in those API docs, you're like, I've never heard of this before.
Right.
What is this?
What is this? Yeah.
Look it up, read it, and then test it. So I think software engineers can build models much faster than people from other backgrounds, just because that's what we do when we're building stuff for anything. But if you need to do the super esoteric, where there's nothing that you find online about how to do this thing, that's when you call a data scientist and be like, how would you approach this problem? Because it might be applying an ensemble of different approaches and doing something very unique that you need to have that foundation of experimentation with models and algorithms to be able to construct something like that. What's your take, Michael?
Yeah, I have 50 things to say. I'll try to limit it to a couple. First, to answer Chuck's original question of whether you need this super fancy job, Ben, I think, was hinting at yes, and I would like to disagree. But one thing that I think you just can't get anywhere else is an understanding of the scale and the types of problems you will encounter. So I can download the Iris data set in R and run linear regression, and great, I'm a data scientist. Can I do that on a terabyte of data, serve that in real time, and then deal with all the problems associated with serving that in real time and the product use case for it? So a lot of these dummy examples, they can get you a sort of a false sense of confidence. And I've from the more academic people I've worked with, especially on the stats side, they freaking hate it when a computer scientist comes in, builds a model, and is like, look, it has 99% accuracy. Well, is that the right kind of accuracy? Is that what we really want to be serving? And it takes a lot of subject matter expertise to delve into what accuracy actually means, for instance. So it really, really depends upon the use case. And I think that you can get that without working the job, but it's so much more efficient if you do want to become a quote unquote expert, or at least pretty good. It really helps to have a strong environment around you, and in a playground where you have data to work with and resources to serve models and that type of thing. If you're rolling everything from scratch, you're going to be limited. But you definitely can pick it all up if you work hard and read a bunch of textbooks and papers. But that's my 2 cents on it. So you don't really need the job to be pretty good or at least solid, but to really understand how to serve a machine learning model and how to build one, I don't know that you can do it not on a job. Maybe in an academic setting, there's large data sets, but it's tough.
I mean, it really depends on what problem you're trying to solve. This isn't an endorsement for doing potentially illegal stuff or anything, but you can scrape websites. You can get data from the internet.
Right.
Don't take personal identifying information or anything, and certainly don't violate terms of service. But there's data out there, and your example was perfect, in my opinion. You're like, hey, NPM packages. How do I determine which ones are related? That's a data science use case, but your training data is out there. It's published, freely available.
Right.
What would you do to figure out which ones are similar? The naive approach would be scrape the website that hosts it. There's some sort of card data associated with each package. The first paragraph of the README or whatever, or something that tags that are associated with it. Scrape all that data and then clean it. And then once you have that, start looking into a graph traversal algorithm. It's like, hey, how many connections do I have in this graph between this package and other similar packages and their connections to one another? So that's just a knowledge graph query. But that's data science work. It's not using, air quote, a model to do that.
Right.
But a lot of stuff that's running in production that's considered AI isn't some, concept of a model. By the way, models are just like numeric weights associated with. It's just metadata that's saved out that is applied to an algorithm that's making some sort of traversal decision or applying it to an equation. So it's important not to if it's like, oh, I'm not saving out like an XGBoost model, so I'm not doing ML. Like, no. XGBoost is just a bunch of tree definitions for decisions that are being made. There's nothing super fancy about it. The cool thing is how fast it is and how good it can be at doing predictions. But your interface to a graph database that solves that problem, that's ML. And it's about figuring out what are your weights for that would be your threshold cutoff. So like, how many connections do I need to return, and what's the threshold to say, hey, if this one NPM package is connected to 30 other ones very strongly, do I want to return all 30? Or do I want to just do the top 5 or the top 7? Or, there's a lot of decisions to be made there. And that's actually what training in ML is doing, is automating that process.
Right.
And you can actually use an off-the-shelf optimizer that will do, use Bayesian methodology to figure out what those optimal values would be. And then you create your own model weights that you're saving off as JSON.
Right.
So it's not that daunting to solve some of these problems. It's just more, how do you think through it? And do you have a buddy that you can ask when you get stuck? And that's super important. If you're doing it outside of company work, get some friends that know what they're doing and that won't get annoyed at answering questions.
It's funny you say that, because I've been lately, one of the things that I've been doing is coaching people on going kind of from junior to senior developer, or, senior to whatever it is they want to do beyond that, right? Whether they want to be well known or contribute to, big things or speak at conferences or whatever. And that's what I tell people is go find some people that you can be friends with, that you can ask these questions of. And now I'm a little embarrassed that I didn't think of that in the first place, right? Is, hey, go make some friends, and hey, I'm trying to do this and I'm running into this snag, and it's like, oh, right, because they've been doing it long enough that a lot of times it's, oh, well, yeah, you have to do this and this in order to make it work. Or sometimes it's, well, we need to know a little more about what you're doing, right? And so they'll ask you the right questions. And some of the time it'll come out as you answer those questions, oh, obviously this is the next right thing. And sometimes, as you answer some of those questions, then they'll be able to point you in the right direction. So that's huge.
Yeah, and the only difference between doing that on your own versus doing that in a company is, in a company, your friends are paid to be nice to you.
Right.
Because that team, your team lead is like, they're pretty motivated to make sure you finish that project. So they got to help you out. But if you're doing it on your own time, you'll just need a bigger network of people that you could have a more, an asynchronous sort of, Q&A with them. And there's some great sort of public community channels out there on Slack and on Discord that you can join about ML. And some of them have industry professionals that are like, hey, been a data scientist for 22 years, and I'll answer questions for free, maybe once a week. And then you have people that are ML engineers that come from software backgrounds. Like, hey, I was an engineer at Google for 12 years and working in their back end for ML serving.
Right.
They probably have the right answer for most of those sort of questions. So I would seek those out and see if you can just make friends.
One more point on that. If you have a goal in mind, often there are shortcuts. So if you're looking to build something, there's almost no, for example, our translation app or our package recommender, there's no doubt implementations that get you 50 to 80% of the way there.
Right.
And so if it's just about implementation, you can do that blindly. It's dangerous. Like, you could be implementing stuff incorrectly, leveraging stuff incorrectly, but the ML model itself can be a black box for a lot of projects. It's just when you need to interpret or leverage the results, then you have to get in a lot more low level and actually understand what's going on.
Well, and that's kind of what I want to cover in the videos I'm planning to put out is, hey, look, here's what we're putting in, here's what we're getting out. And then, then dive in and say, and this is what it's doing. Right.
Right. Yeah. Treating models as inputs and outputs, and there's just a black box in the middle, is actually really helpful. When I'm trying to break down mathematical equations for an algorithm and the math is just too scary, I just want, this is a block. It has an input. It produces this output. I can continue.
And I think the best way to start peeking into that box and really understanding all the components that you need to build a product that leverages ML is just build it. Build it, break it, fix it, ask people questions on it. And then if you have somebody that you can trust, and they're not going to just hammer your public repo that you send a link to them to, but they're going to be constructive and be like, hey, I wouldn't do it this way. Here's a different way to do this, or here's a different way to think about that. If you can get safe code reviews from people who want to see you get better, the faster you build it, the better. Yeah, that's how a lot of us that know a lot about this stuff, that's how we learned. We did it, the hard way, but we didn't do the hard way in a vacuum. We did it the hard way by breaking stuff a lot. And I mean a lot. Generating predictions from models that make 0 sense, or it's so bad that if people actually acted on the results out of these models, the company would be losing money if they trusted that. But evaluating that, showing it to other people, and then asking people from different disciplines. That's how I learned.
Right.
I'll ask some front end developers, be like, hey, does this make sense for this payload that's coming out of this? And they're like, dude, what are you doing? No, that doesn't make sense. And I'm like, oh, maybe I need to think about this. and then ask a data engineer like, hey, having like a little bit of trouble with this data structure that's here. Is this the right way to do this? And they're like, dude, what planet are you from? Like, no, don't parse a tuple like that. Like, here's how you do this. I'm like, oh, that's the story of my entire professional career is just asking questions and not being afraid of people being like, dude, you're dumb. And that's how I've just learned over the years and remembered how nice people were to me when I was, constantly learning. So I try to pay that back to as many people as I can. Like, hey, I can't force you to feel stupid or not feel stupid when you ask a question, but I'm not judging because I was super dumb and now I'm just slightly less dumb because I've learned this stuff over the years. And as long as people understand that and you can provide that feedback to them, it's like it builds this healthy bond, which is a two-way learning street, in my opinion.
Yeah. Well, one thing that I've learned is that most of the time people are pretty happy to answer your questions and help out. Right. I mean, if I'm pushing something at them that's going to take them hours to give me feedback or whatever, sometimes people will let me know they just don't have time, right? Or they'll, hey, I can't get to this now, I'll get to it later. But in a lot of other cases, if it's something that they can look at my code for 10 minutes and give me feedback, or look at my code for 10 minutes and tell me how to get unstuck, even if it's something really fundamental, most people are pretty good about letting me know what it is without giving me and you should already know this, right? Because everybody's been down that learning journey. Everybody gets, hey, I'm kind of new to this, and so I'm going to make some rookie mistakes, or, I'm going to not understand some basic thing that everybody who's been in the field for 5 minutes understands. And so, I almost never get that kind of feedback. I've gotten it at different jobs. Some of these last couple jobs I had, right? It's like, well, how do you not know this? It's in the documentation. And sometimes the answer is, what documentation, right? And so, again, so sometimes the answer is just going to be, here's how you find your answer. But at the end of the day, it all, you're not going to move forward unless you're trying and getting that kind of feedback. And people are kind of the ultimate hack to moving forward quickly.
Yeah. So I'll summarize real quick. I know we're coming up on time.
Yeah.
But there was a lot of really good stuff in here. I tried to capture it all, whether it's in my mind or in my notes. But starting from the baseline, basically, we're looking to figure out how software engineers can move into the ML world. The ML world is absolutely giant, and we highlighted a few professions. So there's product implementation, where you just leverage a existing model and put it into your product. There's also data science modeling specialists, quote unquote. They can be predictive, they can be causal, or they can be research based. And then finally, there's ML infrastructure, or ML ops, where you actually build tools that other people leverage to run models, or to serve them, or to train them. And the skill set for all these includes software engineering, data engineering, stats, other modeling, subject matter, blah, 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 blah. It continues. So what you need to do is essentially inventory your current skill set and figure out what adjacent jobs have overlap, but also have some ML skills that you'll pick up. So you can sort of think of it like a Venn diagram of what do you currently have and then what do you want to learn. And you can do this on your own, but I think the consensus here is that joining a company is the fastest way to become really good. But that said, you can definitely do a bunch of great work on your own and build really cool stuff. And there are essentially two strategies if you want a prescriptive guide. First thing you need to do is inventory your skill set, figure out where you are. Once you know where you are, you can either decide to look where you want to end up or try to find the next best step. So, Chuck, if people want to learn more about you or Top End Devs, where should they go?
TopEndDevs.com is probably the easiest. I'm working on updating the homepage so that it's a little easier to figure out where to go to get what you want. But that's probably the best way. I'm also on Twitter at CMaxW. We have a Mastodon instance that's Chuck at topenddevs.social. Those are kind of the easy ones. You can also email me, Chuck at topenddevs.com.
Cool. Well, until next time, it's been Michael Burke and my co-host,
Ben Wilson.
Have a good day, everyone.
Take it easy. We'll see you
Max
next time.
out, everybody.